Hello fellow map makers, welcome to another live map making session. I hope you're all doing fine and looking forward to another, or hopefully working live map making session with me tonight. I'm Ralph Sherman from Fantasy Software and I'm here to show you a bit of campaign cartographer. Yeah, first off, sorry very much for the technical problems last time. I had internet connection problems. My router just gave out and it took about 15 minutes or so to reconnect and build up for the internet connection to come back on. And by then it was too late to restart anything with the stream. I'm fingers crossed, knock on wood, that nothing like that will happen tonight. The internet's been stable since last week and I can't find anything wrong with the router, so I'm not actually sure what happened there. Good, and sound seems to be fine. Thank you, Sue. A few people are there. Hi, Kevin, Syrian, Vivian, and Kurt. I've seen you there up there as well. Nice for you to drop in. Fortunately, from last week it happened fairly early on, so we didn't lose much mapping in the process. I'll be restarting from scratch today with the same topic, so we'll just start again and hope for the best that we're getting through the map making tonight. Yeah, as one says, it's a computer, it's a PC, Windows even so. Not Windows on the router, obviously, but it's electronic equipment. There's no explanation needed for failure. But what do we want to map today? I'm looking at mapping a solar system. So we are traveling far into outer space. Very fittingly, I have an amazing view of just the moonrise out of my window at the moment. So it's still almost full, the moon. I think we had the full moon a couple of nights ago. And it's I've got an amazing view here. I'll be probably very distracted looking at that beautiful scene out there. But we are mapping planets and also some moons and suns tonight, so that matches that quite well. If you've got any questions during the session, please put them in the chat. We'll be happy to answer them, and if I can, I'll show stuff on screen. If anything is unclear, Sue will forward me any questions, and we'll go from there. Alright, so we are looking at what? We are looking at a template here, if I zoom out for a solar system map from basically the Traveler role-playing game system. That's one of the templates included in Cosmographer 3 that we produced in conjunction with Mark W. Miller for the Traveler system. And it's set up to split the map into 3 distinct regions at different scales because astronomical distances are so huge and varying. So you might have a few stellar bodies quite close together and then a few others very far away. You still want to show them in the same map. And there it's convenient to split a map into different sections where we do have different scales. And these are here, as you can see, called the inner system, outer system, and the remote system. And then we've got different scales. In the first section, distances are measured in light minutes, and in the middle one in light hours. And I think the last one here is even scale in light weeks. Yes, so a lot farther out. Alright, but we do want to start in a fresh map, so I'm going to click the new map icon, save my changes here, and then I'm going to go to the Cosmographer map type. And here I'm going to switch from the decide settings myself, my usual option, to pick a predefined template. That's because this 3-part setup of the map is something that is not easily adjustable in size and scale, and therefore we've provided a fixed template, so you can just pick the one and start from there without bothering about setting any sizes. And I'm just going to find that, and here we are. That's the Traveler large system bitmap. We also have a small system bitmap which just uses one area. But I wanted to show you the 3-part one, so we're going to go for that. And here we are, and that's our empty map. And here we've got some text set up which we can adjust to our liking. So the first thing I want to do, I want to give my system an actual name, and therefore I'm going to do the numeric edit command, click on the baseline on the system name here, and just change this to the title I want for my map. So I'm going to call this the Tomorrow system. Go, and then we've got something. We are not mapping a larger sector where we could give the location in coordinates or something, but I'll just put something in, just have something there. So this is going to be in the Rhine sector, and I'm not going to bother about further giving the location there. It's going to be fine. And then we've got the labels here for the inner, outer, and the remote system. All good. And now we do want to start off. We're going to start out with the inner system, and I do want to put in my sun, my star in the center of the system first. So I'm going to turn on the grid here, just to see where I'm placing stuff. And then I want to load my stars. And for this, here on Cosmographer, we've got the stars symbol catalog, the planets symbol catalog, and then the one for specific traveler symbols, which we probably won't need in this session, but I'm gonna click on the stars. And then we do have two different sets of symbols. We've got the 3D symbols. Those are the ones with a height indicator, but these are used for quasi-isometric maps. And I'm not going to use them in this map. We're going to go for the flat stars instead. And this brings up our selection of differently colored stars. And I want to go, because I want to map a fairly similar to Earth system, solar system, so I'm going to go with a nice yellow sun. There's a whole lot of astrophysics and astrodynamics behind all this, how far livable planets will be around what type of star, and if you are very much into technical detail, and you can get scientific and also gaming material that lets you put in realistic star systems and stuff. I'm not going to bother about this here tonight, so sorry about if I get stuff wrong. We're just going for flavor and showing you the technical stuff you need in the map. So we're going to grab a sun here, and then I want to place this in a central location at the top, and I'm going to then the orbits downwards from there. I could go the other way around. I could start from the bottom, but in this system it's normally that you put this in at the top and go from there. Just checking, this should be about the center point there, in in horizontal direction. But I'm thinking I might want to make the sun a little bit larger. We're gonna have this as a reference on all three of the sections. We're just gonna change the scale. So thinking I could just put this into each of them at different sizes. So let's put the default size in the outer system. There we go. Then let's make this, this is okay, 0.098 at default. Let's make that about 1.5 that size, so 0.03. Oh no, actually 0.3, like that. Oh, but that's a bit too large for my taste, so I'm gonna that's about twice the size and still too large. So 1.5 the size times the size. There we go. That looks about right. And then we're gonna do it quite a bit smaller. So 7.5. No, that's too large. forgot a 0. 0.75. I could of course do this visually. I could just use my mouse to scale it down and place that here. There we go. So that just gives me a little indication of the different scaling. Of course, it's not a matching scale to the astronomical distances, but if I would do that, you'd not see the sun actually. It's too small, just a bright point. Yeah, as Vivan mentions, and I'm thinking that as well, as we discover more and more planetary systems astronomically, we realize how very, very different they can be and how limited our knowledge about the whole thing is. And that's why I'm really not thinking we can make an accurate point about how realistic something is anyway. All right, so I've got my sun down, and now I want to show some orbits. That's the locations where the distance our planets orbit the sun. And we're going to show that with the drawing tool. If we right click our button here, we've got a orbit circle as our drawing tool. So I'm just going to grab that and place it there with the center of the sun where I did that, and then I'm going to look how far away they are. So you can see up here the relative coordinates to the last point I placed. If I go just down, you'll see that the first number is a 0. That's because horizontally I'm not changing my location, but vertically I do. So this is minus 2.5, so about 2.5 units. In this case, we are reckoning in light minutes, so that would be 0.5 light minutes. How far is that? I don't know. I might have a rough idea how far a light year is in numbers, but I don't know what a light minute is at the top of my head. So I'm just going to look at some orbital distances in our solar system, and I can see that Mercury, the first planet from the sun, is 3.3 light minutes away from our sun. So something like this would make a good first orbit. Perhaps the sun is a little bit larger and the first orbit is a little bit further out. So I'm going to put in the coordinate by numbers. I could also just click it with a grid, but then I get the all the fixed distances, which I don't want. I want some variation there. So I'm going to put in an @ for the relative modifier to where I'm at, then the 0, because I don't want to change the horizontal location of my next point. And then I'm going to do a minus 3.6. There we go. And now we've got our first orbit down here. If I do a selection, you'll see that it does not extend beyond this edge here. That's because there's a map border there. Basically, the map border goes around all the 3 rectangles here, and the drawing tool is limited to the map border, so the tool just cuts off the circle at that point, which is nice, which is what we want. So let's put in the first planet there, just to show you how to do that, because we already got the suns down, so we're going to switch to the planets now. And here also got the same distinction like with the stars, 3D version and a flat version. I want the flat version. And then we do have some different planetary symbols here. You can see we've got some special stuff like the Dyson sphere and some colorings and an asteroid belt or just an asteroid symbol. We can also expand all the collections to show all the ones, because we've got the several life-bearing planets, we've got the water planets, we've got dry planets, and so on. And for the first planet that's close to the sun, it's unlikely that it is bearing any life because it's going to be too hot. So I'll just grab a hostile planet here, and then see, this is perhaps, let's zoom in a bit. It's a bit large in comparison to the sun, so I do want a bit of a smaller scale. Again, I don't want a realistic scale to the sun, otherwise the planet will just vanish. So we are gonna do a 0.05. Yeah, that sounds about right, or looks about right. And now we can either put it on the somewhere off to the side and switch things around a little bit to put text in different places, or we could do the more typical scientific thing of showing them all in a row. And here I'm just going to go to do a little bit of placing it at different locations on the orbit. So I'm going to use F9 to place the center of the symbol on the orbit. That way it will be centered on there. There we go. And there's our first planet. There we go. And then we can put in some text to name this. And for that we'll take a look here with what we've got in the setups. I can grab a link to that text here. See, we've got the labels here. And can change stuff, but here I'll need a light text, obviously. So I'm gonna grab a light gray, very light gray. Or I might actually grab a very light blue. Might also look good. See whether we've got, no, we only got the one text. That's fine. And then I'm gonna put in some description. So we could just name this in the typical scientific version of numbering the planetary bodies in a system according to their order in from the sun. So that would be the Damaris 1. Well, and I believe that this perhaps it's a recently colonized system in a larger colonial empire or something, and they haven't bothered about naming the other bodies in the system for something specific. Just the main world will have a different name, so I'm just going to call this Damaris 1. And could put in any other notes here about the planet, but what I'm here just going to put in is a numerical indication of the distance. So I said 3.3 light minutes, so let's just call it light minutes and leave it at that. And then you see this is a bit large, so I'm going to make that a little bit smaller. Let's have a zoom out, see how, yeah, that looks about this and good size for this kind of map. So I'll put that in there. Let's have a quick look at our text properties. Yes, it's 0.4 Verdana. Could go for something a little bit more science fiction-like. Take a look. Well, let's have a look whether we perhaps want to change this to a different text property. So I'm going to grab this and go for more fonts and see whether I've got something. I've got the nasalization font, which I quite like. It's inspired by the official NASA logo. So let's grab that. Let's have a look how that looks. Yeah, I love that. That looks nice for a science fiction map. So I'm gonna just grab the extract properties now. Actually, I might go for what I always, it's just a pet peeve of mine. I'm just gonna do this and drop the extra digits from the height there, so I have someone that I can remember easily. So default text here will be 0.4 height. Click OK, and then use extract properties again, so it's the default text set in the map. There we go. And we've got our first planet down. So next up we are gonna look for more planets, more orbits. So I'm gonna go for the orbit again. Here I can, of course I can use the snap here again. What I can also now do is use F4 modifier, that's the center point modifier on the existing orbit. I know that doesn't actually work because it's cut off. Okay, so we'll just grab the same location here again. There's actually something I did last time, I remember now, which I might do here again, because it can be quite useful. What I'm going to do is I'm going to set the origin of the map to to our sun here. So I'm going to go move origin, and with the snap turned on, click this as our new center point for the coordinate system in the map. Now if I pick the orbit again, I can also just put in 0.0, and that will easily grab that location. Alright, so I'm looking at my list of orbital distances in our solar system. So Venus is about 6 light minutes away from the Sun. So I'm gonna put in my new point again, like last time, at 0, let's do 5.8, a little bit closer than Venus. And now I'm going to continue on putting in the orbits first, because since I'm working on orbits at the moment anyway, I can just right click and I get the same center point again. And I'm going to go at 0. Next up would be Earth, that's 8.3, so light minutes away from the Sun, so let's do 9.4. Got a bit of a gap there, and then I'm thinking we might have another one which is fairly close, so analogous to Mars, but perhaps closer. So I'm going to do in at 0, 10.9. No, I'm problem is that my at coordinates I'm using not the 0 now, but they're using put down in reference to the last point I'm placed. That's why the distances are getting so large. I'm not referencing 0,0, the origin. When I put in the at sign, I put reference the last placed point. So I need to drop the at. So because I've got the origin here now in the center of the Sun, I can do that. I can, if you show you, I can do distance. So and from here to here, to F9, it's 15.2. This is actually this point, and then 9.4 would I add it to here. So we're going to redo that. I'm going to delete these two orbits, and I'm gonna do a new orbit, start at 0, 0, and just put in 0, 9.4, and see I'm much closer now. That's because the distance I put in is from here now instead of from here. Okay, and now I can put in 0, 10.9, and I'm at the location I was planning. Alright, what you can see now is that our orbit extends into the next section here, into the outer system. That's because we only have the one map border around the whole thing. We can't have interior map borders here that would cut off the orbit. So this appears in here. And what we need to do, we need to trim this ourselves. But that's easily done. We've got the trim command here. Grab that, click the orbit, click on the point here between them, and that trims this section here, and we are limited to our inner system. Alright, so we've got these down here. The next up in the list in the solar system is already 43 minutes away, light minutes away. So we're going to put in a couple more orbits, but we'll have a bigger gap here. So I'm going to grab the orbit again, center point 0, 0, and I'm thinking, just taking a look here how far this is away. So this is about 30 light minutes away. So I'm going to put in 0.31. And then I'm going to put in one here, or actually I should put in the absolute coordinates here, so we can actually see this distance from the sun. So 45.5. So let's do 0,44.7. Then I'm gonna trim the 2 orbits I've got in here. There we are. And we've got all the orbits in our inner system. Now I just need to put some planets on. So I'm going to grab another dry planet here for the second. Then our most important, our life-bearing planet here is going to be on this orbit. And this one I'm going to place in the center here. So it's the important thing to place. And then perhaps I'm thinking I might actually put a second, perhaps pretty frozen planet. This looks pretty frozen on the next orbit. Then we are going for some larger planets like Saturn and Jupiter, so gas giants basically on the next orbit, and these will just make larger. Show that. Here we go. So we want to place one on this orbit, and then this one, perhaps a little bit smaller again, on this orbit. I can see from this, even from this scaling, you can see the planets nicely. And now we just need to place the text for these. Could also turn on our sheet effects. See, that blurs the orbits a little bit and makes them less. It makes them a little bit transparent. Okay, so I'm gonna call the next one just Damaros 2. And I forget how far away we placed it. Okay, so we're just going to place the name first. I'm going to align it a little bit differently on the left side there. I'm going to turn off snap actually. And I forgot how far away my planet there was, specifically since I did use the relative coordinates there. How do we find that out? Well, fairly easily. Because we've used the correct scaling for the orbits, we can just go info distance from 0, 0 to this orbit here. And that's going to select that with F9 on. And there we can see we've got 5.799, so almost 5 point. Let's call that 5.8. And then I'm just going to edit this text here and make that multi-line and put in 5.8 light minutes. There we go. And then we're going to do the next text. And now I'm thinking this is our main world. And I say it's a colony, and it's named after the first colonist or the captain of the colony ship or something. So call it something like Humboldt's world, or it might actually be named after the German explorer Alexander von Humboldt. Who knows? Just call it Humboldt's world. Oops, what did I do wrong? Somehow, okay. Not sure what I did there. Humboldt's world. And we placed that at 9.4 light minutes from the sun. Bottom, align it here. Got a question there from Sue, if I can find it. Whether this traveler template was included in Cosmographer or added via an annual. This is actually included in Cosmographer 3. You can find some example files. I think there's a short section on how to use these in the Essentials guide that comes with Cosmographer. but there's not a mapping guide like there's for the annuals for this one. So, but it's really fairly easy to use. So then next up we've got the ice world here, and we am gonna call that let's call it something like after something Nordic. Let's call it Jotunheim, the home of the ice giants in Nordic lore. Jotunheim actually, but just gonna spell it a little bit differently. And that was 10.9 light minutes on my scale here. Right, top and place. So next system, and then we've got some the names for the gas giants. Again, here I measure my distance again because I've got a bad memory. I forgot where how far away I placed them. F9 to here, so that was 30.1, and I think this was 44 point something. 0 to here, 44.7. Yeah, okay. So let's call this. Now we're going back to the numbering system again. So this would be Damaris 1, 2, 3, 4 actually in the numbering. And so this would be Damaris 5. Damaris 5. And that's 30.1 light minutes away. Not 20, but 30. And there I placed accidentally right-clicked, and that jumped the text to below the previous text. So instead I'm going to move it to where I want to place it. There we go. And then we've got Damaris 6 at 44.7 light minutes away. Left alignment, bottom, and place it here. There we are. And we've got the first things down here. We've got other stuff going on into the solar system, of course. And for one thing is that we have in the solar system is an asteroid belt, an area where a lot of small bodies are circling the sun. And we are going to do this as well with a little showing that. So we are gonna go for a I'm gonna go for an orbit again, but this time I'm gonna just I'm gonna grab the same thing, but I'm gonna actually delineate an area. So I'm gonna go from here to here. Then I'm gonna trim these again, so it's only in the inner system. And then we've got some tools here for dust clouds and asteroid belt areas. And I'm gonna grab that, and I'm just gonna outline this area to show that this is not one in a single body, but more like a area of special interest. There we go. See, we've got the gray dust in here, and we are going to put in some text as the asteroid belt. Center, just going to put that in here. You might do stuff like perhaps there might be a special place, a large asteroid that's used as a mining station or a refueling station or even a settlement or something. So we're going to make this a bit smaller. Let's make that 0.1. Place that here, perhaps a little bit of the inner edge. and then we'll give that, let's call this Cosmographer station. Top left, bottom left, put it here. There we go. They've got something of interest going on. So thinking I could mark these two limits of the asteroid belt. Probably these are some limits of a certain density of celestial objects. So if I want to label the distance of these, I'm just going to measure them and go from info distance from 0.0 again to here. Just have to be careful to actually hit. So I've got a 21.14 around it. So I'm just going to put this 21.14 light minutes at the inner limit. And then I'm gonna info distance from 0 to here. That's 24.13. So 24.13 light minutes. And this is the outer limit of this area. And there we do have a nice map of the inner system, of the inner Damaros system. From there, I can go on and put in some farther away ones in the outer system. And there, but we've got to decide now about our scaling. So we do have, we're saying it's in light hours. So it's actually already 60 times the distance from these ones. 60 minutes in 1 hour. So even for the distance that calculates the same relation. And if we take a look at Uranus or Neptune in the solar system, for example, they are 2.7 or 4.2 light hours away from the Sun. So if we're using the same scaling here, then we are going to be a lot farther away. So if we just say the same distance, so for example, if I put in a orbit to here, although we do need to move our origin now again, if we want to use the Sun here now as the center point, as the relation, and then we're going to just move the origin again. If you move origin, place it here. And then we are, if I, for example, put in the orbit of Neptune in there, so let's say I'm going to grab the orbit here, go from here, and then place it at 0.4.2. You'll see that it's fairly small, although it does kind of work. But we could do stuff like put in a scaling factor, say we do double the size on the on this one, so 1 unit would be only half a light year here. So we do have a bit more space in there. Then we could just double this size and keep that in mind, put that down as a note, or scale our map for the time being. But I think I'll stay with this type of scaling and just make just assume that this fits fairly well. Alright, so that's one orbit. Next up, I'm gonna go 0, 0 again and take a look at my coordinates here. So here is about 27. So I'm just going to put in 0,27.8, and one more down here, fairly far out at 52 light minutes, so 0.52 here. And now you can see that these orbits extend into the left and the right column again, because I don't have a map border entity here. So I do need to trim these twice. Once in this direction, oops, I was a bit too far. Once in this direction, same here. And now we've got them limited to the center section again. And then we can put in some planets again. Let's grab something a bit alien, smaller, F9 on here. And then something larger out here. And then perhaps we might even look at something really alien, science fiction like we've got, I think we've got something for a wormhole. We might have an orbiting wormhole, or even a Dyson sphere, basically a Dyson sphere. Although true Dyson spheres around the sun, actually, not so that wouldn't be fitting. So let's grab a wormhole. Let's just have to look how large the symbol is. Works. Just rotate it a little bit. Could make it a little bit larger. Put this on here. And so perhaps in our setting, wormholes is how ships travel into this interstellar distances. So if we've got a wormhole here at the edge of the outer system, and that's where ships would arrive and would have to travel into the inner system to get there. And I've got some suggestions from Bill to things that would be fun to consider on the map. Some asteroids like Ceres are big enough to be around dwarf planets. And to adding the Trojans, especially to the gas giants, would be fun. Oh yes, of course. Trojan points are gravitational points along the, if I remember correctly, along the orbit, basically before and behind the gas giant, where the astromechanics basically collect stuff. But I'm not entirely sure, and I'm gonna leave this to others to add to the maps. Oh, yeah, that's the Lagrange points actually. As Sue mentions. Oh, I didn't brush up on my astrophysics enough, so I'll leave that for others to do. All right, so one thing to consider in systems, what is a common thing actually in astrophysics, is a companion sun, or basically a double system or even triple systems where stars orbit around each other. They can be either fairly close to each other, or you can have a smaller star orbiting at huge distances around another one, and this is I think a good place to put into the remote system. So let's do that, and this would be pretty far away, and with the light weeks there, we're acting pretty good as for a distance there. Otherwise, if it would be too close, the mechanics and the gravitational pull from another sun would probably bring the whole system into disorder and basically destroy it before it could form any significant planets. But if the star is far enough away, it's certainly possible to have planets inside the orbit of the outer star. So we're going to put in another orbit, and this time we're going to move the origin to here. Orbit is here, and let's do it fairly far out, something like 45.2, just using the grid here now, or 43.5 light weeks is it what we have here out here. Now I need to trim this again. And now I could go to our suns again and grab a little red dwarf or something. Grab this and place that on the remote orbit here. Let's make it small so it looks distant. And now we could name this and you call this, usually in systems like this with multiple suns, you tend to call them in with Greek names. So the central star would be Damaros Alpha. So we just got to call this here Damaros Beta. Oops, actually I wanted to multi-line there. Damaros Beta. Let's call that the Red Dwarf Companion. At, what did I do? Say 43.5 light weeks. Distance. There we are. And this is where I accidentally right-clicked the other text. And what we can also show here on the map is on this one the limit of the inner system, for example. So say if I have the distance here in light minutes, that's 44.7 light minutes divided by 60 would give us the light hours. So if I put this, go in here, let's move our origin once more to here. Now I'm gonna grab the small circle in here, and then I'm gonna do 0, comma, and I'm gonna not calculate the extent myself. I let Cosmographer calculate that, so I'm gonna put in 44.7 divided by 60. There we go, and as you can see, it's just a tiny bit around the sun there that actually would be the inner system, hardly noticeable and hard to depict. That's why you break this out into section, or what you could of course also do is do a logarithmic scale. And because it's too close, I'm not going to bother about including it here. I'm just going to remove that again. It doesn't really do much on the map. Alright, so we've got that, and I do need labels here for the interior things, so I'm gonna put in Damaros 7. So about that, I was a misclick because I remembered I need to check my distance for the orbit here. F9. No, we didn't want this so long. There we go. So it's got 4.2 what we put in here. So Damaros 7 at 4.2 light hours. Then the next one, info distance from 0 to here was 27.8. 27.8 light hours. And finally, info distance from here to the wormhole orbit, that was 62. Wormhole 62 light hours. So I'm still gonna take almost 3 days if at light speed from there to the center of the system. It's still quite a journey. There we go. And finally, we would put in the orbit numbers in here. And so, for example, here we've got shown the orbits 0 to 6. 0 is the sun itself, and the outermost is the 6. Then we've got the orbits 7, 8, and 9 here. 7 to 9. And this would be the order orbits 10 and plus. There might, of course, be empty orbits on a system like this. We might include those and show them. But I think you get the idea there. And that's, actually what I do want to add is a label for the sun. So this is going to be the Mars Alpha. Each time, zoom in here. Bottom center. Yeah, and then I'm just going to copy this to here and here. And with that, I would have my map done. I could, of course, add more details and specific things like Trojans and Lagrange points and special asteroids. We could actually, I want to put in another asteroid in here. I'm going to follow Bill's suggestion and put something that's more planet-like. Larger objects tend to form into globes, or more regular globes. That's why we get the planets. And so let's grab one of this one, the gray one here, seems to be fine. And then I'm just gonna put this in here. And what if I now want to also add the orbitable line for this one? I did place this first. So what I'm gonna do is I'm gonna grab this. I'm gonna grab the small version. I did not move the origin, so I can't use 0, 0. So what I'm going to do instead is I'm going to grab the snap point. And then I'm just going to go in visually and place the orbit in here. And then I'm going to trim the orbit again. And what I want to show that it's not the major planetary body, I want to make this the orbit a dashed line. So what I'm going to do is I'm going to right click the change properties button and choose change line style. Going do it, right click, and then I get to the line styles, see whether we already got something that might be. No, we do have the dash line, dash style, so let's do a dash. But as we can see, this is a very large dash. So what I'm going to do is I'm going to use extract properties to select that dash line style up here. And now I'm going to edit it and say I don't want paper scale. I want instead of, say, my section is 1 unit. Let's have a look how this looks. Still a bit too large and unfortunately also a bit irregular here. So, oops. So another go at that. Let's remove the draw first section, but we'll actually do scale to fit ends sometimes and make a 0.25. One of the, that's how long one repeat of the pattern is. No, actually what I'm doing wrong. What I need to edit is the pattern length and not the line style section here. That's stupid. So I need to change this one here. 0.25. Working on the wrong entry. That's better. That's how I imagined that. See, now I've got the dotted line for that orbit. And I'm going to move this around a little bit because I've got something new in there. I want to make some space and also put in a name for this. Let's make it a little bit scary. Let's call it Death's Head. And put this just to the right of our celestial object there. And there we've got another object, another place to be in the asteroid belt. All right. Now we can export this. We could do just sections if we wanted to. We can do the whole thing. Let's do a little quick test. Do a save as. I want to do a JPEG bitmap file. Actually, I want to do a rectangular section, because otherwise let's just grab the map border, and some stuff here is outside of the map border. I can set this size here, 3000 by 3000. 3000 as the maximum size seems to be good. Then I'm going to go where I want to save this. Parentheses streams. System map and the Damaro system. Gonna turn on snap so I can grab some fixed points. There we go, and that's our export, and it should come up in Photoshop. And let's make that fit into the video screen. And there's our exported map, which we can put anywhere else we need it. We also need if you want to keep the FCW file, because we started from a fixed template and not one from the change your own or define your own settings. We need to actually save this under in the location we want it. Again, go to the video streams, current session, and again the Damaro system. And there we are, and that's it for today. I'd say we've mapped the whole star system with a number of different locations and on 3 different sections of the system: inner, outer, and the remote system. And that didn't take too long, did it? Alright, that was a bit... normally today would have been me showing off the latest annual issue, but because of the technical problems last week, I did want to do this here tonight, and we'll do the annual issue next week. So, a bit of patience, but you can already play around with that if you want to. Thank you very much for watching. Hope you enjoyed tonight's session without any technical problems. Yay! And fingers crossed it's going to stay that way for the next weeks. Alright, as always, if you did enjoy our little YouTube hour, please give the video a like or subscribe to our channel, and that will help us be a little bit more visible on YouTube. Excellent, have a good night, and see you again next week. Bye bye.